An AI just decoded the first message from a creature that has been speaking in the deep ocean for 30 million years. The message was not a warning. It was not a threat. It was the simplest thing any living being has ever said, and the scientists who heard it for the first time went completely silent. This is not a story about technology. This is a story about what we have been missing while we were busy building the world above the surface, and what has been living below it, watching us, talking about us, for longer than our species has been able to stand upright. Something has been speaking in the dark at the bottom of every ocean on Earth for 30 million years. For almost all of that time, we had no idea. Then, an AI processed 9,000 recordings from the deep water off the Caribbean island of Dominica and found something that researchers from MIT, Harvard, and UC Berkeley were not prepared for. What the machine found inside those recordings was not random animal noise. It was a structured communication system with its own phonetics, its own grammar, its own way of layering meaning across long distances through total darkness. And in November 2025, UC Berkeley linguist Gasper Begush, who leads the linguistics work at Project CD, the Cetacean Translation Initiative, published research that stopped the scientific world cold. The sounds these whales make are not clicks in the way science had always assumed. They are vowels, acoustically and structurally identical to human vowels, and no one had ever seen anything like it in any other animal. To understand why this discovery matters so much, you need to know how the story started. And it started not in a laboratory or a research vessel, but in a hallway at Harvard. Marine biologist David Gruber was sitting alone in his office with headphones on, reviewing old recordings of sperm whale sounds he had collected years earlier while studying something completely different. Through his headphones came a rapid sequence of mechanical clicks, firing in precise patterns with specific gaps between each one. He had heard these sounds hundreds of times before. Every time he had taken his headphones off and moved on, assuming what he was listening to was just background animal noise from a creature science had already figured out. Then MIT cryptographer Shafi Goldwasser walked past his open office door and stopped. She stood in the doorway for a long moment, listening. Then she looked at Gruber and said something that changed everything. She told him it sounded like Morse code. She asked him whether anyone had ever tried running those sounds through a machine learning decoding system. Goldwasser had spent her career breaking actual encrypted government communications, the kind that nations use to hide their most sensitive intelligence from each other. When those whale clicks came through Gruber's headphones, her professional instincts fired immediately. She was not making a casual observation. She was recognizing the architecture of a hidden code, and nobody had ever tried decoding it. In all the decades of whale research, across every ocean study ever conducted in every laboratory that had ever analyzed cetacean sounds, nobody had run those clicks through a decoding system. They had been sitting there untouched, waiting for someone who had spent their life breaking codes to walk past an open door. That moment in the hallway started something that could not be stopped. In 2020, Gruber formally launched Project CD, which stands for Cetacean Translation Initiative. The project brought together researchers from MIT's Computer Science and AI Laboratory, Harvard, UC Berkeley, and 15 additional institutions. The team included marine biologists, cryptographers, AI researchers, linguists, roboticists, and underwater acoustic engineers. They chose Dominica as their base of operations, a small Caribbean island surrounded by one of the only stretches of ocean on Earth, where multi-generational sperm whale families return year after year without fail. These were not anonymous animals passing through. The families were known, the matriarchs had names, their social relationships had been tracked across decades of careful observation. This was the closest thing to a whale neighborhood science had ever found. What the team deployed in those waters was unlike anything previously used in marine biology. Permanently installed underwater microphone arrays positioned along migration routes, tags attached directly to whale skin using suction cups, each one carrying 3 synchronized microphones capable of isolating a single voice inside a group conversation. GPS trackers, depth sensors, temperature recorders, and accelerometers, measuring every tiny shift in body position to a fraction of a degree. The system was not simply designed to hear the whales, it was engineered to capture who was speaking, who they were speaking to, what they were physically doing at that exact moment, and what the entire acoustic environment around them looked like at the same time. 9,000 recordings went into the AI. What came back out shattered 40 years of assumptions. For decades, scientists believed they had sperm whale communication essentially mapped. The prevailing theory was that these animals used roughly 21 distinct click patterns called codas, each one carrying a single fixed meaning, like signals on a traffic light. No combination, no building, no layering of meaning. The AI destroyed that theory completely. It identified 156 distinct codas. But the number alone was not what stopped the researchers in their tracks. What stopped them was what was buried inside each coda. Every single one had 4 internal elements that could each be independently adjusted to change its meaning. Tempo, the speed at which the clicks come out, distinguishing urgent communication from calm routine. Rhythm, the spacing between individual clicks, whether grouped tightly or spread wide. Ornamentation, extra clicks embedded in the middle of a pattern that shift its meaning entirely, the same way a single added word can reverse what a sentence says. And rub, microscopic timing variations that carry emotional texture, the way a voice tightens when its owner is frightened versus softens when they feel safe. These four elements working together form the engine of a full communication system capable of producing layered meaning that no single click could carry on its own. Scientists have a specific name for a communication system that works this way. It is called duality of patterning, the ability to build an unlimited range of meaning from a small number of fundamental units. It was considered a defining property of human language. The AI found it working inside an animal, clicking in complete darkness a mile underwater. Then the system found something nobody had prepared for at all. The same whale used different communication styles depending on who it was addressing. Researchers call this audience design. In human language, it is what allows you to speak differently to a child than to a colleague, to soften a message for someone who is suffering, to adjust what you say based on your understanding of who is listening. Audience design does not just require language. It does not just require memory. It requires a working model of another individual's inner world, the understanding that other beings have their own separate experiences, their own knowledge, their own emotional states. The AI found what appears to be theory of mind embedded inside click sequences in an animal we had spent generations treating as producing noise. Then came the most disorienting discovery of all. In November 2025, UC Berkeley's Gasper Begush published the results of his team's acoustic analysis. When the sperm whale recordings were slowed down and examined at a deep level, what researchers saw inside the sounds was not what anyone expected. The whales were producing vowels, not sounds vaguely similar to vowels, not rough approximations, acoustically and geometrically structured patterns that were identical to human vowels. Begush identified two primary types. The first matches the A sound in the word father. The second matches the E sound in the word see. The system also contained diphthongs, gliding combinations where one vowel sound moves smoothly into another, like the OI in the word boy. When the sound shapes were mapped visually, they were exact acoustic matches for human vowel structures. Begush stated it plainly in his published findings. He said that in the past, researchers had thought of whale communication as a kind of Morse code. But this research shows their calls are more like very, very slow vowels. He said directly that this suggests a complexity that approaches human language. And then he added four words that lingered far longer than anything else in the paper. He said he had never seen anything like it in any other animal. To understand why that matters, you need to understand what producing vowels actually requires. It demands very specific anatomy, a descended larynx sitting low in the throat, precise muscle control in the tongue and jaw, controlled airflow through a shaped resonance chamber that functions as a tuning instrument. In humans, this anatomy evolved over millions of years under very specific pressure towards spoken language. The combination was considered biologically unique to our lineage. Sperm whales have none of that anatomy. Their vocal system evolved in the deep ocean in total darkness under thousands of pounds of water pressure for an entirely different purpose: echolocation. The ability to send sound beams into absolute dark and read the returning echoes to build a picture of the surrounding environment, the same way a bat navigates at night. They did not evolve toward language. They evolved toward something that, when analyzed by the most advanced acoustic equipment available, looks functionally identical to it. This is called convergent evolution. Two completely separate species, on completely different evolutionary paths, with no shared ancestor for hundreds of millions of years, independently arriving at the same complex solution. The creator built two completely different paths in two completely different creatures, and both of them arrived at structured, intentional communication. Dr. Daniela Roos from MIT, who directs CSAL, described the findings carefully. The results show there is far more complexity here than previously believed, and this is challenging the current understanding of the animal world. Here is the detail that almost never makes it into the news coverage. The same organ that produces these gentle, structured vowel-like sounds inside a sperm whale's enormous head is the exact same organ that produces its hunting click. Sperm whales are the loudest animals on Earth. Their clicks have been recorded at 230 decibels underwater. A jet engine at close range registers around 140. Human eardrums begin to rupture at 150. At 180, internal organs begin to fail. The organ that produces structured communication is the exact same organ that can stop a human heart without making physical contact. The language and the weapon are in the same place, and the whale has been using the language for 30 million years without anyone realizing it. The ocean had already sent researchers a warning long before any AI had processed a single recording. Researcher Oscar Palacios and his team were in the Galapagos Islands running an acoustic study on a pod of 25 sperm whales. Underwater microphones were in the water. The study was going normally. Then, one day, everything went silent. Not gradually, not one whale and then another. All 25 went completely quiet at exactly the same moment. Then the entire pod disappeared. The researchers searched. Nothing. The conclusion they reached is genuinely difficult to sit with. They believe the pod detected that underwater microphones were present. They believe the whales recognized they were being monitored, communicated among themselves about it, and made a collective group decision to go silent. 25 animals coordinating a shared silence in direct response to human surveillance equipment. These creatures had figured out that humans were listening to them long before humans had any idea what they were actually saying. Consider also this detail that rarely gets mentioned in the coverage. Sperm whale calves are not born already knowing their language. Exactly like human infants who spend their first year producing broken, partial sounds before recognizable words emerge, sperm whale calves babble. They produce messy, incomplete attempts at the click patterns of their family group, practicing repeatedly, getting it wrong, trying again in complete darkness, while their mothers are on deep hunting dives hundreds of meters below the surface. Among the very first patterns a calf learns is something researchers call the identity coda, the specific click sequence that marks which family this animal belongs to. A sound-based family name learned in the earliest weeks of life and carried for the next 70 years. The first lesson a sperm whale receives is not how to hunt, it is not how to find food or stay safe, it is who it belongs to. From the very first sounds it ever makes, this animal is already operating inside a language system built on identity, belonging, and social rules that existed long before it was born. The AI also revealed something that went far beyond clicks. Out of the full library of 156 codas with vowels, grammar, and audience design all confirmed, researchers have quietly identified one specific pattern they believe they may have partially understood. It is called the 1 + 1 + 3. 2 isolated clicks, a brief pause, then 3 faster clicks grouped together. It is the most widely documented coda across Caribbean sperm whale families. It appears across the widest range of social situations, before deep dives, after surfacing, during group gatherings, at births. Researchers are now cautiously proposing it may carry a meaning close to, I am here. That is the first message. Not a complex warning, not a demand, just presence. One living thing telling another that it exists. That phrase has been transmitted between sperm whales millions of times across 30 million years in a language humans could not read while we were hunting them. The first thing we may have understood a sperm whale to say is the same thing every conscious being eventually needs to say. I am here. It has been saying it every day to every family member in every ocean since long before our species could stand upright. The most chilling evidence that sperm whale communication operates across vast distances did not come from a laboratory. It came from old handwritten journals. When American whalers first arrived in the Pacific in the early 19th century, their operations went well. They found whales, then something changed. Within just 2.5 years of their arrival, the number of successful strikes dropped by 58%. The whales had not moved to a different ocean. They had simply begun evading ships with a consistency that had not existed before. What had happened was that the whales who survived early attacks had passed a warning through their communication network, not just to nearby animals, but to whales that had never seen a hunting vessel in their entire lives. Animals living thousands of miles away began changing their behavior based on information received through clicks from whales they may never have met. Historian Beth Sheba Desmuth at Brown University worked through the old whaling journals and found entry after entry in which sailors described this shift with unmistakable discomfort, writing that the animals appeared to be talking to each other and that whatever the younger whales were doing, they had clearly learned it from somewhere. The whalers felt it happening. They had no language to explain it. The journals also recorded something that had always been dismissed as distress noise. After a whale was harpooned and dying at the surface, the rest of the pod would go completely still. Then, the clicking would begin again, intense and different from anything the sailors had heard before. Those sounds were never decoded, but we now know these animals have 156 codas, a working grammar, vowels, and the ability to tailor communication to specific individuals. Whatever was transmitted in those moments was a real thing being said in a real language. It was heard by men on wooden ships who wrote it down and kept sailing. In 2020, something new began off the coast of Portugal. Orcas, the largest members of the dolphin family, began targeting sailing vessels, specifically their rudders, biting and bending and snapping them off. By 2024, there had been at least 500 documented incidents and 3 confirmed sunk vessels. Marine biologists traced the behavior back to a single starting point. A female orca believed to have experienced a traumatic encounter with a boat in 2020. She taught the technique to members of her pod. They taught others. Within months, the behavior had spread through the wider population. Animals that had never experienced the original event learned a specific, targeted technique through social transmission. Through language, 30 scientists signed an open letter urging the public not to attribute human motivations to the orcas. But those same scientists also wrote clearly that the orca is an intelligent, socially complex species, and that each population carries its own culture, its own vocalizations, its own hunting techniques, its own social structures. They admitted plainly that science cannot yet fully explain why the orcas are doing this. The explanation is in a language we still cannot completely read. Project CD has now partnered with NYU School of Law to explore what AI-assisted whale translation means for animal rights law. In 2024, indigenous peoples from New Zealand and the Cook Islands signed a landmark treaty formally recognizing whales as legal persons with specific rights. Gaspar Begusch said directly that the researchers are thinking deeply about what finding human-like structures in whale communication means for the legal rights of animals. He asked the questions out loud in a published statement. What is language? Is there anything uniquely human about it? Or is it a continuum? What does that mean for the law? These are not abstract philosophical questions anymore. They are questions backed by published, peer-reviewed science produced by some of the most respected research institutions on Earth. What we are doing to these animals while this science is developing is worth sitting with honestly. A sperm whale can live 70 years. The matriarch of a family alive today may have been born before underwater sonar existed. She has spent her entire life transmitting knowledge to her daughters and granddaughters, the best hunting grounds, the safest migration corridors, the dangers to avoid, the geography of an ocean learned across decades and passed down through structured sound. When a family dies out, it takes with it generations of accumulated knowledge about the ocean that no other family carries. Knowledge stored not in books, but in language. Industrial shipping now fills the world's oceans with engine noise that never stops. Military sonar sends shockwaves through the deep. Seismic blasting from fossil fuel operations and deep-sea mining detonates through every ocean basin on a continuous basis. For an animal that lives in a world where sound replaces sight entirely, where every family conversation and every cultural transmission across generations happens through an acoustic channel, this is not pollution in any ordinary sense. Researchers have written it plainly. A deaf whale is a dead whale. Chronic exposure drives animals away from feeding grounds, floods their bodies with stress hormones, and fractures the acoustic fabric holding family groups together. Ship strikes alone kill an estimated 20,000 whales every year. If sperm whales carry language and transmit cultural memory across generations, then every ship that struck a whale and kept moving did not simply kill an animal. It silenced a speaker mid-sentence. What all of this adds up to is something that takes a moment to fully absorb. These animals watched their families get harpooned and kept talking. They watched 2/3 of their species disappear across the 20th century and kept talking. They watched the ocean fill with noise that tears their world apart and kept talking. If their language can carry warnings across thousands of miles and memories across hundreds of years, if it contains vowels and grammar and the ability to address individuals by understanding their inner lives, then what they have been saying about the species that hunted them to the edge of extinction has been accumulating for a very long time. The first message researchers decoded was, "I am here." Simple, ancient, the same thing every conscious being created with the capacity for connection eventually needs to say. But the longer message, the one these animals have been transmitting about us through their communication network across entire ocean populations, is something we have not yet fully translated. Perhaps because some part of us already suspects what it says, that we are the most consequential force that has ever entered their world, and they have known it far longer than we have. The first message was not sent when we started listening. It was being sent 30 million years before we built the machine to finally hear it. And we are only now, in this moment in history, beginning to understand what it says.